All right, let's talk about one of the biggest headaches in AI today, hallucinations. We're going to break down how you can tame them using a really powerful technique called Retrieval-Augmented Generation, or RAG. And we'll look at a super practical, two-pronged approach using something called ChromaDB and a clever little fallback plan. Let's dive in.
So let's start with the big question, right? Why do these incredibly powerful, super smart AI models sometimes just make stuff up? It can feel pretty random, but there's actually a really clear reason for it. And once you understand that reason, you're already halfway to solving the problem.
The fancy term for this is an AI hallucination. But really, all it means is that the AI is guessing. It's not trying to lie to you. It's just that when it doesn't know the answer for sure, its programming kind of pushes it to fill in the gaps. The scary part is, it can do this with answers that sound incredibly convincing, but are totally wrong.
So how do we stop the guessing? Well, the solution is actually pretty elegant. We just stop it from guessing. We do that by grounding its answers. Instead of letting it roam free across all the data it was trained on, we basically tell it, hey, from now on, you can only use the information inside these specific documents to answer questions. That's it.
This whole process, this grounding, is called Retrieval-Augmented Generation. You can think of it like a four-step dance. First, you split your documents into smaller, bite-sized chunks. Second, you convert those chunks into a special numerical format called embeddings. Third, when a user asks a question, your system retrieves the most relevant chunks. And finally, you hand only that very specific context over to the AI to generate its answer.
Okay, so the workflow makes sense in theory, but how do we actually build this thing? Let's get practical and look at the toolbox. We're going to explore two different paths you can take to build a really effective RAG system.
Now, before we dive into those two paths, a quick heads up on our strategy. We're using Dash Scope for the embeddings. Why? Because it keeps everything really lightweight and easy to manage, which is perfect for a workshop like this. We also embed things in small batches so we don't overwhelm any servers. The goal here is efficiency and keeping things simple.
All right, let's look at our main approach. Path A is what I call the ChromaDB way. This uses a specialized tool, a vector database, and it's our first choice for a reason. It's the high-performance option.
So what's so great about ChromaDB? Well, for starters, it stores all those numerical embeddings right on your local machine, which makes searching for context incredibly fast. The performance is just fantastic if the installation goes smoothly. You should know, though, that on some computers, it might do a one-time download in the background when you first set it up.
And, that brings us to that moment every single developer has experienced. You're trying to install something new and error message, it fails. We've all been there. So what do you do when your preferred path is blocked? You don't just give up.
You have a backup. Meet Plan B. Now, this isn't some lesser, second-best option. Think of it as your smart, reliable fallback that's designed to just work, no matter what. It's the pragmatic choice for when things don't go exactly as planned.
The beauty of Plan B is just how simple it is. There are no heavy, complicated libraries to install for the main search part. It just uses standard math, cosine similarity, to find the best context. And it's smart too. It caches the embeddings for speed, but automatically re-indexes everything if you so much as change a comma in the source document.
So let's just put them side by side. On one hand, you've got Path A, ChromaDB, which gives you that lightning-fast search from a dedicated local database. On the other hand, you've got Path B, our fallback, which gives you dead simple reliability with zero installation headaches. The right choice really depends on your setup, but having both options makes your whole system incredibly robust.
Okay, so we have our tools, and we have our two paths to get there. But here's the thing. The tools alone will not stop hallucinations. You also have to enforce some rules. Think of this next part as setting the rules of engagement for your AI. This is the discipline it has to follow to give you clean, trustworthy answers.
This quote really gets to the point. This isn't just some academic thought experiment. This is how you actually do it. This is how you make these systems reliable enough to use in a real live product.
It really all comes down to a few very firm rules. There are two non-negotiable commands for the AI. Number one, it must answer using only the context we provided. No outside knowledge allowed. And number two, if the answer isn't in that context, it must say that it doesn't know. It cannot guess, period. Sticking to these rules is absolutely the key to killing hallucinations.
So, we've covered the theory, the tools, and the rules. But honestly, the best way to really get a feel for this is to roll up your sleeves and get your hands dirty. Now it's your turn to put this whole system to the test and see it work for yourself.
So here's a little experiment you can run. First, go into the source document and just change something. Watch how Plan B automatically reindexes itself. It's pretty cool. Next, ask the same questions to both Path A and Path B and compare what they spit out. And finally, start messing with the top K parameter. That controls how many chunks of context get sent to the AI, and just watch how it changes the quality of the answers.
And that really brings us to the final question. Once you get past that fear of hallucinations, once you have a system that you can actually trust, one that gives you reliable, grounded answers based on your data, what are you going to build with that? The possibilities are really something to think about. Thanks for watching.